Okay, so let's start today's lecture. Okay, so now in the last week, we have been talking about the first chapter of ordinary differential equations, in which we discussed such notions like the basic principles of differential equations and how do you model natural phenomena. In that example, we were talking about the bloodstream problem, drug administration in the bloodstream problem, right? So it's kind of, and we have been trying to solve this differential equation. And we see such important notions as, for example, the general solution versus the specific solution, right? So how do we integrate the equation to obtain a solution? And then we talked about things like classification of ordinary differential equations, right? So we can classify an ordinary differential equation by its order, right? So, and we can also classify an ordinary differential equation by whether or not it is a linear or nonlinear equations, right? So nonlinear equations. So these are important notions that we have been talking about in the last week's lectures, right? So in last week's lectures, okay. So now starting from this week and from this time on, we will be talking about solving, okay, so solving differential equations. Okay, so we will be talking about solving differential equation. Okay, so we'll be talking about solving differential equations. Okay, so now I would like to first give you an impression. Okay, so I like to first give you an impression, namely, okay, so I like to first give you an impression, namely, what's the major, okay, so what's the major rationale of the rest of these lectures about how to solve differential equations. Okay, so now we're going to solve, try to talk about how to solve differential equations from orders, right? So we're going to classify. Okay, so now classify, right? So let's say we can classify, right? So classify a differential equation by order, right? So that's order. So that means we're going to have first order equation, right? First order equation, second order equation, right? So, and then in general, nth order equation, right? So for different orders of these differential equations, we're going to talk about how to solve them. In particular, the second order up to the nth order equation are one part of these lectures, and the first order equation is one part of those lectures, okay, these lectures. And we're also going to talk about, mainly talk about how to solve linear equations. Okay, so we're going to have a systematic theory. Okay, so remember, we've been talking about classification of these equations by linear or nonlinear equations, right? So it can happen that you're going to talk about either linear or nonlinear equations. Okay, so now we're going to talk about the classifications of these equations. The solutions via linear equations, and a little bit about nonlinear equations. Okay, so a little bit about nonlinear equations, and that's the main plan of the rest of the semester. What we are going to, what kind of equations we're going to talk about for the rest of the semester. Okay, so. And so therefore, let's come back to today's lecture. Okay, so that's so today's lecture is very simple. Okay, so as the plan goes, we will be first talking about first order equations, right? So, and once we talked about first order equations, we are going to start talking about second order and the higher order equation. So therefore, we will be spending some time. Okay, so we'll be spending some time to talk about first order equations. Okay, so first order equation. Now, how are we going to solve first order equations? Okay, so how are we going to solve first order equations, right? So we're going to solve the first order differential equations by several. So what's the general first order equation? Okay, so What's the general first order equation? Well, the general first order equation should look like something like this, right? So it has the form, let's say dy over dt is equal to f and t and y. So here, as we discussed previously, it is important to keep in mind which one is the function and which one is the variable. So here what happened here is that y is a function of t, right? So y is a function of t. T is the variable and y is the function, right? So y is a function of t. Now, if that is the case, then you can of course say the equation has the form dy over dx is fxy is also completely fine. You can say that this means that y is going to be a function of x, right? Y is going to be a function of x. So now today we are going to talk about one way to solve such differential equation. It's called separation of variables. Okay, so by separation of variables, it kind of applies to a very particular case of this general first order equation, in the sense that the right-hand side is a so-called separable form. Okay, so the right-hand side is separable form. So I'm going to use dy over dx, but then I'm going to say this is m of x divided by n of y. So that's kind of the way to say that the equation is in a separable form. Okay, so why do we want to say an equation in a separable form? Well, if you look at the original equation, okay, so if you look at the original equation, then you start to realize of the problem. Okay, so you started to realize of the following kind of problem, namely, you're not able to just integrate this equation, because if you integrate this equation, you integrate y of t minus y of 0, then it's the integral from 0 to t, f t y dt, but you don't know what this is y is. You don't know what this y is. You never are able to integrate this equation. So that's kind of in a certain sense. And we understand that solving a differential equation actually is kind of reduced to integrating this equation, right? So that's basically we're saying that solving is in a certain sense integrating. Right, so solving and is integrating. So these are the same things in a certain sense. Therefore, you want to find a way to integrate this form. Thus, this form is called a separable. Okay, so by writing the equation in a separable form, we say it is indeed possible to integrate it, because this equation can be written as n of y dy is equal to m of x dx. So you can write it in this way. Right, so you just do a cross product of these two. N of y dy is m of x dx, and from each side you're going to see n of y dy is equal to the m of x dx. These are antiderivatives. So that means you get certain relations. Okay, so let me say if the antiderivative is this calligraphic n, right? So n of y plus c1. Then it's equal to the calligraphic m of x plus c2. So indeed, it's kind of a relation saying that n of y, right? So a function of y is equal to a function of x plus a constant. So that's kind of a relation between the solutions of y and x. Although it's not explicit, but it is better than the differential equation, because now you don't see any derivatives. You have get rid of your derivatives by doing integrations, right? So you have already get rid of the derivatives by doing integrations. So that's what you actually is trying to think about this question, right? So that's how you actually is trying to think about this question, right? So that's kind of how you think about this question. Now, once you have this, okay, so once you have this, you can see that this form of the solution is called a solution. Okay, so in implicit form. So we're going to call it a solution in implicit form, because it's not an explicit way to represent the solution. But you can see that from here, maybe by algebraic manipulations, you get y equal to y of x, right? So that's a solution. This is a solution, right? So this is a solution in explicit form. Right, so the solutions can be implicit or explicit, depending on how you represent the solutions. Okay, so this is kind of a pretty abstract way to talk about the separation of variables, separation of variables. Okay, so now the rest of today's lecture, I'm going to do a lot of examples. Okay, so I probably will do at least 3 examples for separation of variable. But before I do that, let me ask you the following question. Okay, so as I said last time, whenever you have questions during a lecture, or whenever I was asking you to talk about yours, how you think about a certain question, and you can freely talk in the lectures when such opportunities come up. And if you have questions, it is rather welcomed. Okay, so you are very welcome and encouraged to raise them. Okay, so now in order to answer questions, you can just click the microphone like button, which is unmute yourself in the chat. And then, unmute yourself, and then you just speak to your microphone. I will be able to hear you. Okay, so you are very welcome to raise any questions that you would like to have. Okay, so now let's come back to this. Okay, so I would like to say, okay, so let's say separable form. Okay, so an equation in a separable form can take the form dy over dx is m of x divided by n over y, right? So n of y, so that's a separable form. Now I'm asking you the question, for example, if I write the equation dy over dx is equal to n of y divided by m of x, I flip the sides, is it going to be a separable form? Anybody has idea? I mean, no. Is this, somebody says it's no, right? So because we just flipped these two, the relations between these two equations. But I'm going to say, okay, so unfortunately, I'm going to tell you that it is, okay, this is a separable form. Why is that the case? Because it can be written as 1 over m of x divided by 1 over n of y. Do you agree with me? Right, so it actually doesn't quite matter if n of y and m of x change their positions. Because in this way, your separable form is going to be written like dy over n of y is equal to dx over m of x, and you still are able to integrate it, right? So, but I would like to strongly encourage that guy who just answered no, right? So it is you are very welcome to talk and let me know how you think about certain problem during the lectures. It will help me and us everybody a lot in better understanding what is going on in this lecture, especially under the online form. Okay, so you are very welcome and encouraged to answer these questions. Please don't be shy and don't worry whether or not you're going to make mistake. Okay, so it doesn't matter at all. Okay, so now it means that this kind of, you can be very flexible with the separations of variables, because the separation of variable essentially is just saying that you want to collect x on one side, you want to collect y on one side, and do an integral on both sides. So that's kind of what happens to separation of variables. So let me ask a question. Suppose the equation now is something like this, is equal to m of x multiplied by n of y. Is it in a separable form? Now anybody has can answer again, or that guy? Can you answer this again?
It is.
It is, right? So this time you're starting to get the point, right? So why? Because this can actually be written as m of x divided by 1 over n of y. You can write it this way. And if that is the case, you're able to write this equation like dy over n of y is equal to m of x dx. Again, it's a separable form, and you can still integrate, right? So that's kind of, I'm just trying to say that the equations in a separable form can be very flexible. Okay, so they can be very flexible, and you have to, the only principle that we would like to have is to collect the variables x on one side and collect the variables y on the other side. So that's the major point why we want to have separable forms of these differential equations. Okay, so as we have separable forms of these differential equations. Okay, so now with all this attempt, we're going to talk about a few examples of solving differential equations using separation of variables. Okay, so now I would like to say that these lecture notes are all available. Okay, so because of the online instructions, I have kind of released them all at once, all of them at once in your Canvas website. If you go to Canvas, you're able to see all these lecture notes. And in particular, this lecture notes involves previous year's exam problems. And these exam problems are going to help you a lot for understanding and especially for preparing of your midterms and finals. Okay, so that's kind of just to they are kind of prepared in order to assist you with any kind of exams you're going to encounter during these lectures. Okay, so that's why I say it's very important to come to the lectures. And for this semester, you have actually the online teaching gives us such a benefit that you're able to view those videos even after the class, right? So it's, if you get if there's something missed, it doesn't matter. You can just watch the videos and you still have it. Okay, so that's kind of the advantage. Okay, let's look at this problem. Okay, so when I say spring 2016 exam 1 number 1, it means that it was from this exam problems which you can find on the Canvas student resources webpage. Okay, so now this is the spring 2016 exam 1. Okay, so we're going to work on this problem number 1. Okay, so problem number 1 says, can you find the general solution of this equation, right? So it's example 1, right? So can you find this equation of this equation is y prime is t e t minus 1, right? So y prime is t times e t minus 1. So that's kind of this equation, right? So this is this equation. Now we want to solve this equation. What should we do? Well, if you don't know how to do it, you may rewrite this equation as dy over dt is equal to t times e power t minus 1. And then you have to recognize that this equation is in a separable form, right? So why this equation is in a separable form? Because it is in the form of a product, right? So it is the equation is in the form of a product, and therefore you're able to write this equation, for example, as t e power t divided by e power 1, right? So t e power t divided by e power 1, right? So you're able to write it this way. Now, if you write this equation this way, then you are able to do a separable form. E power y dy is t times e power t dt. And from here, you can integrate on both sides of this equation. E power y dy is equal to e power t dt, right? So multiplied by t. Now, for the left-hand side, it's just e power y, right? So let's say plus constant, C1, right? So what about the right-hand side? Anybody has idea? You can unmute yourself. How do you integrate t e power t? Anybody has idea? How should we integrate t e power t? Anybody has idea? I want to integrate t times e power t. What should I do? Anyone has idea?
Integration by part.
Integration by parts, right? So thank you very much. I like this answer, right? So it is exactly the case. And if somebody has already forgotten about integration by parts, I would strongly suggest you to review it whenever you have time. Okay, so this is a very important operation in calculus. Integration by parts tells us that here I have to treat t as the t and e power t as the antiderivative, and then minus the integral, right? So minus the integral of t derivative, and e power t keeps there, e power t dt. So that's going to give me e power t minus e power t plus another constant c2. So once you have c1 and c2, essentially you're trying to say that e power y is t e power t minus e power t plus a constant, which means that the solution y is equal to logarithm of t e power t minus e power t plus constant. So that's kind of the way how you treat a separation of variables, right? So you get a solution. So you can look. Let's look at the exams. It's just the solution is like this, right? So you just do this, and you just do the integration by parts, and you're going to get the solution. So that's a nice example. Okay, so that's a nice example how you're going to do this problem. Okay, so let me show you two more exercises, and then one more exercise, and then I'll move to the next section. Okay, so now this one says, can you look at fall semester 2015 final exam? So we're going to look at fall semester 2015 and final. So this is how a final exam is going to look like, right? So this is how a final exam is going to look like. How many problems are there? Well, you can see there are 10 problems there. And usually for the final exam, you have 120 minutes. So about 12 minutes for each problem. And in some, it is going to be 200 points. Okay, 200 points. Now let's look at the first, the problem number. Okay, so let me see which problem it is. Final number 1. Okay, so let's look at problem number 1. Okay, so this one says, can you find, okay, so find the explicit solution of the initial value problem. Okay, so find the explicit solution of the initial value problem. Okay, so an explicit solution of the initial value problem. So I would like to give you such a small, okay, so I would like to give you such a small tip on your exams is that whenever you see, okay, so whenever you see problems on an exam, the important thing is the first important thing is to look at the statement of the problem very carefully before you start to do anything, right? So look at the statement of this problem very carefully before you started to do anything. Okay, so and here it's important to see that the question says, I want to find an explicit solution of this initial value problem. So this is an initial value problem, and I just want to find an explicit solution. So that means we have to find a general solution, and with the initial conditions, we have to also find a particular solution. Okay, so now what's the problem equation? Okay, so the equation, okay, so the example 2, right? So the equation here is talking about y prime plus 2ty. Okay, so y prime plus 2t of y is equal to, okay, so it is equal to t multiplied by y squared with the initial condition y0 is equal to 4, right? So y0 is equal to 4. Now with this equation at hand, first of all, you have to determine, can you use integration by, can you use the separation of variables? Well, we can write this equation as dy over dt. First of all, when you look at differential equation, you must recognize that this is a function of y in terms of t, right? So we're looking for the function y, and the function y has to be in terms of t. Let me say that this is ty squared minus 2t of y, which can be written as t multiplied by y squared minus 2y. So it can be written in this way. If it is written in this way, you can recognize that it is easy to do separation of variables. Y squared minus 2 times y is equal to t times dt. Right? So that's it's easy to say, see from here that indeed you're using a kind of a separation of variables, right? So you're using a kind of separation of variables. Now, as long as you have this, you just want to integrate on both sides of this equation. So dy over y squared minus 2y is the integral of t dt, right? So that's going to have this. Now, what's the right-hand side? Well, the right-hand side by classical integration is just 1/2 t squared plus constant. Now the question is, can you integrate, right? So can you integrate the integral of dy over y squared minus 2y? Are you able to integrate this? What should we do? Well, if you don't know what should we do, look at, so this is a very general principle in these lectures, is that if you see quadratic forms, right? So here is like y squared minus 2y, it's like a quadratic form. When you see any quadratic forms in this class, there are 2 ways to do quadratic form. So by quadratic form, it means ay squared plus by plus c, right? So any quadratic form. There are either 2 ways to do quadratic form. One way is to write it as y minus alpha 1, y minus alpha 2. You just factorize it, right? So you just factorize such a quadratic form. So that's the first way of thinking about quadratic form, right? So first way of thinking about the quadratic form. Another way to think about the quadratic form is to write this as a times y maybe minus alpha squared plus beta. What does this mean? It means that whenever this quadratic form is not able to be separated, to be factorized, you should complete a square. So right, this is called completing the square. So you either do a factorization or you do completing the square. So indeed, what happened here is the case that you can do factorization. You just divide, factorize the denominator into y multiplied by y minus 2. Is that good for everybody? Okay, so Now, how do we integrate this form of this antiderivative? Anybody has idea? I want to hear from you. Anybody has idea how should we integrate dy over y multiplied by y minus 2? Anyone has idea? How should we do this integral? Anybody has idea? Anybody has idea? In your calculus class, what kind of method can help us to solve this problem? To solve this problem, do you have anything that comes to your mind? What kind of method can help us to integrate an antiderivative, to find an antiderivative of this form? Anybody has idea? Oh, okay, so there is a method, right? So there is a method that we learn in calculus. It's called partial fraction decomposition, right? So it's called partial fraction decompositions, right? So maybe you forgot about it, but I'm sure that this method is included in your calculus textbook. What does it mean, partial fraction decompositions? Okay, so what does it mean, partial fraction what does it mean, partial fraction? I will answer those questions raised in the chat, maybe by the end of the class. Okay, so what's about partial fraction decomposition? Partial fraction decomposition simply says that you're able to say, let's say y minus 2 is equal to a over y plus b over y minus 2, if I can remind you. Right, so it's, you can go back to your calculus textbook, and there must be such a method. Okay, so, and it doesn't quite matter if you forgot about this method. We're going to come back to this method sooner or later in this class. But here, I would say there is such a fractional decomposition, which means that further you can write this as y minus 2, a multiplied by y minus 2 plus b of y, and then how are you going to determine a and b? Well, it's going to be a plus b multiplied by y minus 2 times a divided by y over y minus 2. So that's going to give us a relation that a plus b is equal to 0 and minus 2 times a is 1. So that from here, you're going to just obtain that a is equal to minus 1/2 and b is equal to 1/2. Therefore, their sum is 0. Right? So that's kind of the important thing. For partial fraction decompositions, it is going to tell you that y multiplied by y minus 2 is actually equal to minus 1 over 2, right? So a is minus 1 over 2, and then it's multiplied by 1 over y plus 1 over 2 multiplied by y minus 2. That's it. So you're going to be able to write everything like this. And if you write everything like this, you want to integrate with respect to dy, it will be very simple. So you integrate with respect to dy. This is going to be minus 1/2. Remember, integration of 1 over y is logarithm of the absolute value of y plus the integration of logarithm of the absolute value of y minus 2. So that's going to be 1/2 of the logarithm of y minus 2 divided by y. So that's what happens to this partial fraction decompositions, right? So as long as you have this, you come back to this equation, it's going to tell you that 1/2 of the logarithm of y minus 2 divided by y is going to be equal to your integral is 1/2 t squared plus a constant. So further, it simply says that logarithm of y minus 2 over y is equal to t squared plus constant. Here, the constant is actually 2 constant, but it doesn't matter. So that kind of tells us that y minus 2 over y, just in absolute value, is equal to e power t squared plus constant is kind of c e power t squared. And therefore, it tells you that y minus 2 over y is actually plus minus c e power t squared. But the plus minus is k, so it's just a constant k, no matter you choose plus or minus. So that's kind of tell you that 1 minus 2 over y is equal to k e power t squared. So that's going to tell you that 2 over y is equal to 1 minus k e power t squared. So in the end, y of t is being solved. It's going to be 2 over 1 minus k e power t squared. So that's kind of the way how you get a general solution of your problem, right? So that's kind of how you get a general solution of your problem, right? So general solution of your problem. Now, I would like to say, okay, so I have kind of reminded everybody that it is very important, right? So I have reminded everybody that it is very important whenever you go to the lectures, right, or the exams of this class. Okay, so whenever you're going to the exams of this class, you must realize, okay, so you must realize that it is very important, okay, it's very important that you look at the instructions of the problems very carefully, right? So now if you look at the instruction here, it is not finished, right? So you have not really finished your goal, because here the question, okay, so here the question is just to say, okay, so it's just to say, here is just to say that we would like to find the initial value problem. So you must put the initial values there. Otherwise, you have not finished your problem and you cannot get full credit. So that's kind of very important tip I give to everybody is that whenever you come to the exams of this class, you must look at the problems carefully. Okay, so you must look at the problem carefully. So here the problem says y0 is 4. So what if y0 is 4? Well, y of 0 is equal to 2 over, this is 0, so that's 1 minus k is 4. So k must be 1/2, right? So that kind of tells you k is 1/2. Once you know k, you can put 1/2 here. That's going to be your solution. Okay, so your final solution. So I'm not going to go much in the detail. Everything is simple for the rest. Once you get k is half, you get a solution y of t is 4 over 2 minus e power t squared. So that's kind of how you get your solution in a particular form. Okay, in a particular form. So this is kind of, from these two examples, we really kind of see how to make use of the separation of variables to solve a differential equation. Okay, so let me quickly show you one more example. This is from this example 3, first semester 2014 and final. Okay, so let's look at fourth semester 2014 and final exam number 1, right? So you can see that this one is kind of the equation, something like this. But again, you can see that this is a first order equation and it's going to be separable. You integrate and you find the solution. So I'm not going to talk much about this example, okay, just to leave it to you as a nice thing to see. Okay, so now I would like to show you, okay, so I would like to show you just one more example. Before I do that, I would like to remind you that usually, okay, so usually in our lecture notes, there's going to be a lot of examples, a lot more than what we can cover during a lecture. Okay, so why do we have so many examples? Because some of them are left to you as an exercise. Okay, so some people were asking, how do you find those formal exam problems? Please go to Canvas, right? So go to Canvas, click all courses, and then browse more courses. Then you're going to click courses. From courses, you go to all courses, and then browse more courses. You'll be able to see all the exam, and you're able to see a page called Student Resources for 3304, and you find all these problems. Okay, so if you have questions related to that, you can go and ask about this for your peers. Okay, so and it is important to have access to all the previous year's exam problems, and from there you're able to combine it with our lecture notes and practice by yourself. Okay, and practice by yourself. So let us now look at, okay, so let us now look at, okay, so look at this one more example that I would like to just to show you. Okay, so let's see one more example I would like to just to show you. Okay, so let me find it first. Okay, so let me find it first. Okay, so this is 2018. Okay, so this on this one. Okay, so I think so. There was an exam problem that was quite interesting and definitely worth talking about. So I think it's somewhere probably here. Yeah, so this question. Okay, so let's look at this problem. Okay, so this problem says, can you find an explicit solution of this equation? Okay, so that's kind of a, it looks very weird equation. Okay, so this example. Okay, so let's see example 3. Can you find an explicit solution of this equation? Y prime, okay, so y prime is equal to t plus y minus 1 squared, right? So t plus 1, y minus 1 squared. Can you find a solution of this equation? Well, if you want to find this solution, as I said, you must be able to rewrite the equation as a separable form. So dy over dt is equal to t plus y minus 1 squared. Is that good, everybody? Right? So now the question is this equation in such a form separable?
No.
No, somebody says it's no, right? So I would like to thank you for such an answer, right? So I'd like to thank you for such an answer. Somebody says no, you're not separable, right? It looks like it is right. So it looks like it's indeed non-separable. But then you look at the problem. Okay, so this was a hard problem during that exam. Here it says that you can change variables by letting v equal to t. So what does it mean? Well, if you change variables, so v is t plus y minus 1, it looks like the equation becomes dy over dt is equal to v squared. Is it separable? Anybody has idea? It's not separable again, because even if you come back to this equation, it comes to another variable. So it looks like very puzzling, right? So it looks like very puzzling and don't know how to really solve this equation, right? So a lot of people during that exam got stuck in this problem. And how do we do that? Well, the important thing is that once v, remember, here y is a function of t. Y is y of t. So if you say v is t plus y minus 1, is actually saying that this v is a function of t also. Is that good for everybody? Right? So therefore, we can consider differential. So dv is actually dt plus dy minus 1. Is that good for everybody? Right? So dv is actually dt plus dy minus, and there is no minus 1 because I'm taking differential. Maybe it's better. Maybe it's better to say it in the following way. Okay, so maybe it's better to say that because y is a function, is regarded as a function of t, dv over dt is just 1 plus dy over dt. It's just 1 plus dy over dt, right? So that's dv over dt is simply 1 plus dy over dt, right? So you're going to have this. Okay, so now as long as you have this, it means that once you get dy over dt is v squared, this is actually 1 plus v squared. So the equation now becomes dv over dt is equal to 1 plus v squared. Now, if you come to this equation, okay, so if you come to this equation, the question is this separable, right? So it is separable. Well, now it's, anybody has idea? Anybody can tell me how you think about this equation? Is it separable or not separable? Any idea? Anybody has idea about how you think of this equation? Is it separable? Is it not separable? Anyone has idea?
It is separable.
This is separable, right? So you're actually, this equation is the same thing as this one, but this one is very puzzling because you have the y. So that means in order to do a change of variable, you have to change very thoroughly. You have to change y into v everywhere in the equation and then become separable. You can say that this is dv, 1 plus v squared is dt. So that can actually tell you that arctangent v is equal to t plus c. So v is actually tangent of t plus c. You see what I mean, right? So the integration of the 1 over v squared, 1 over 1 plus v squared is arctangent. And so you have this relation. Now, is this the end of the story? Well, it's not the end of the story because v is actually not your y. When you want to solve this equation, you want to say y is something. But v is equal to t plus y minus 1, from which you can immediately see that y is solved. Y is just equal to, okay, so it's just equal to tangent of t plus c, right? So plus 1 minus t, that's it. Because t plus y minus 1 is tangent, so y is just this solution. So this is the way how you solve such a pretty weird problem in one of those exams. Okay, so yeah, this is how you solve such a pretty weird problem in one of those exams. And you have to be very flexible. Okay, so I can tell you that during that exam, a lot of people lost their points on this problem because it's just too weird. Okay, so but here today, I have just went over such a problem. I hope it helps you to get better understanding of what is the method of separation of variables. Okay, so that's kind of separation of variables. Now let me just briefly summarize separation of variables. Okay, so now let me say that if you have an equation in a separable form, right? So if you have an equation, so basically separation of variables. Okay, so separation of variables. Right, so if you have an equation in a separable form, then it must look like dy over dx is equal to m of x divided by n of y in general, right? So what happens in today's lecture is that we also talked about possibilities of changing this equation, right? So it might be m of x multiplied by n of y, maybe, right? So it might also be, for example, m of x and n of y divided by m of x, that's also a separable form. So there are actually many different ways to talk about separable forms of equations. Okay, separable forms of equations. Now, the question I'm going to ask everybody is the following question. How many of you think that this equation is linear? We've been talking about linear and nonlinear equations, if you remember, right? So now I would like to ask you the question, how many of you think that this equation is linear? How many of you think this equation is linear? Is there anybody think this equation is linear? Or maybe I ask the following question. Can you tell me this equation is linear or nonlinear equation? How do you think? Any idea? Can you tell me if this is a linear or nonlinear equation? How do you think? Any idea?
Is it non-linear?
It's a nonlinear equation. Okay, so this is very good. Okay, so in general, yeah, I mean it's the precise answer. One should say hard to determine. For example, maybe n of y is just equal to 1. Then the equation is dy over dx. Maybe it's just m of x. And this will be linear equation, right? So linear non-homogeneous, right? So because the y prime, this y prime is just equal to m of x, and this is a function of x. This is just a coefficient in 1. It will be linear. But in general, it will be nonlinear because the equation is like n of y dy is equal to m of x dx. It violates our formula for the linear equation because the linear equation must have coefficients like a of x. It must be coefficients independent of y. Here, in general, is nonlinear. So in general, nonlinear. Right? So in general, it is a nonlinear equation. So that's kind of very important observation. It's just telling us that an equation in a separable form, in general, is not a linear equation. As we said at the beginning of this lecture, we want to talk about solving a differential equation in a linear or nonlinear form. So that means, as a summary, we know that for today's lecture, we've been talking about solving differential equation using the method of separation of variables. And this method actually applies mainly, okay, so actually applies mainly to nonlinear equations, right? So mainly to nonlinear first order equations. Okay, so mainly to nonlinear first order equations. Okay, so that's kind of the thing about the method of separation of variables. Okay, so that's kind of the thing I would like to say about the separation of variables. Okay, so let me remind you that we are still in the category of talking about first order equations. Okay, so we're still in the category of talking about first order equations. In the next lecture, we're going to talk about linear. Okay, so we've been talking about nonlinear first order equation. So in the next lecture, I will be talking about linear first order equations, and then we're going to continue from there. Okay, so we're going to continue from there. Okay, so that's probably all I want to say for today's lecture. Okay, so I would like to continue from the next lecture and still talking about linear first order equation, but then we'll be talking about linear equations. Okay.